Amusement rides have been my one love for over a decade. This video will cover inspections, audits, codes, standards, and prevention in amusements, all crucial in quality control. Anything that touches the industry impacts me directly as an avid consumer. It's beneficial to know what you're getting into, and this class has demonstrated that specifically with manufacturing, which is a field I desire. To keep guest sound and your reputation in check, the industry has strict measures on safety and quality. If you visited an amusement park recently, you've actively seen the measures done for your enjoyment. The first forms of quality control come during the design of any ride. ASTM F2291-21, Standards for Amusement Ride Design and Construction, provides rigorous ride safety and structural integrity guidelines. Central to the design process is a comprehensive ride analysis conducted by engineers to identify potential hazards and mitigate risks associated with the ride's use. This analysis must account for all expected interactions with patrons and maintenance personnel, assessing risks from physical contact with ride elements and the environment. Designers must systematically categorize all equipment and scenarios within the analysis, specifying use cases and excluding non-relevant items. Each identified hazard must be managed to an acceptable level, achieved by reducing the hazard severity, the likelihood of occurrence, or both. Risk mitigation methods are chosen to avoid introducing new hazards or aggravating existing risks. A hazard assessment is necessary, incorporating environmental conditions, load and unloading activities, patron suitability based on age, size, and anthropometric data, and failure modes. Failure assessments use fault tree analysis, failure mode and effects analysis, or similar engineering practices to identify potential breakdowns in safety-critical systems. The structural requirements of any amusement rides are particular to each component, including mechanical, electrical, and control systems, and are verified through rigorous calculations. These analyses must account for predictable stresses and forces that will act on the ride during routine and emergency scenarios. Calculations should use established load paths and coordinate systems with validation methods for each major ride component. Additionally, rides design must incorporate patron restraint and containment systems tailored to the ride's dynamics and the intended patron's physical attributes. Restraint types such as bars, seatbelts, or cages are selected based on a detailed patron analysis and associated acceleration forces to ensure patrons remain safely contained throughout the ride cycle. Restraint configurations vary by class, ranging from minimal restraint for low acceleration rides to redundant locking mechanisms for high acceleration or inverting experiences. A critical part of the design process is the patron clearance envelope, which establishes a minimum distance between the patron and surrounding ride structures or other patrons, minimizing contact risk. The clearance envelope must allow for patron size and movement variations, preventing injuries due to accidental contact. Designers must consider factors such as patron reach, height, and surrounding surface characteristics to ensure any objects within reach are devoid of hazardous features, like sharp edges or pinch points. Where patron-to-patron contact is expected, such as in shared seating arrangements, additional analysis ensures that the interaction remains within safe limits. Further, acceleration limits define the permissible forces patrons may experience. These limits are categorized by axis, sustained duration, and restraint type. New rides must undergo testing to verify that operational accelerations remain within these limits, ensuring patrons are not subjected to excessive forces. The same code emphasizes ongoing inspection, detection, and procedure to preserve safety and operational reliability. The standard mandates that maintenance practices be tightly integrated with the design analysis, ensuring that potential hazards identified in the ride's life cycle are addressed through preventive and corrective actions. Routine inspections are critical as they allow for early detection of wear, deterioration, or potential failures in safety-critical components. These inspections cover a broad spectrum from basic visual checks to more detailed NDT on structural elements, such as welds or parts that may degrade over time. Maintenance personnel must periodically test operational functions, such as control systems and safety interlocks, to verify that they are working as intended. Regular testing of components, such as restraints, load-bearing structures, and mechanical assemblies, ensures that all systems meet performance standards under real-world conditions. Documentation plays a significant role in maintenance by providing operators with clear, detailed instructions on performing safe and effective operational procedures. This documentation should also outline operator responsibilities, specifying all required actions related to hazard mitigation, such as resets, emergency response, or patron evacuation protocols. Maintenance records should highlight any component modifications, with updates to original design specifications noted to ensure compliance with safety standards over time. In addition, operator training is fundamental. Operators must be thoroughly trained on each ride's operational requirements, including emergency procedures and how to safely disable or secure the ride for repair, ensuring that operators and maintenance staff can manage routine procedures and emergency actions. IROC, or International Ride Operator Certification, is a common third-party training program and inspires most training at parks that choose not to participate. IROC ensures that operators are trained in a manner that maximizes comprehension and retention of fundamental safe operating concepts, while staying up to date on the industry's best practices and standards. To receive certification to operate any attraction at compliant parks, you must read the program's hand and textbook and pass a tedious written exam. You must showcase competency of their material during training by a certified instructor or trainer. International Ride Training, the company behind IROC, conducts unannounced audits at parks. Ride Operations Performance Observation includes videotaped ride operator performance and additional unrecorded observed cycles. Audit will include random sampling of 12 rides to include a mix of high-thrill, flat, circular, and children's rides. All video recordings, narrative audit report, and audit assessment spreadsheets provided to facility management at the conclusion of each audit and exit meeting of approximately 90 minutes, with ride operations management to discuss audit results, review selected audit video, discuss any trends that may arise as second and third audits are completed, and discuss recommended corrective actions and potential strategies for implementation. The Ride Operations Compliance Audit assesses operations documentation for compliance with ASTM and local jurisdiction requirements, including but not limited to ASTM F770 and ASTM F2376. All standards covered provide amusement parks and engineering teams with a reliable framework for conducting essential safety practices such as preventative maintenance, operator training, audits, and inspections. These standards help parks identify and prevent potential hazards, promoting a safety culture across the industry. Currently, amusement attractions are required to follow ASTM standards in 44 states. These regulations require parks to adhere to guidelines for ride design, construction, and operational practices to ensure public safety and maintain operational consistency. However, 6 states, Alabama, Mississippi, Montana, Nevada, Wyoming, and Utah, have opted not to enforce these standards. It's important to note that these states have relatively few large-scale amusement parks compared to others, and most of their attractions tend to be smaller, often temporary setups such as fair rides, which may be subject to local rather than state-level oversight. Without enforced regulations, parks in these states operate with less external scrutiny, placing responsibility of maintaining safety standards primarily on the park management. I'd like to end this with a few notes. Your chance of dying on a roller coaster is currently 1 in 750 million. This is due to the extreme measures and standards and quality control the industry upholds. Non-destructive testing, specifically X-ray and magnetic field testing, is common with amusement rides. This class has been insightful, and I've enjoyed watching these forms of NDT in action, and look forward to using them in the future. hopefully with amusement rides.